Hello and welcome to our webinar. Webinar topic today is overview of concrete overlays, existing pavement evaluation and overlay selection. Our presenters today will be Peter Taylor, Director of the CP Tech Center, Gordon Smith, Associate Director of the CP Tech Center, and Greg Dean, the Director of the Carolinas Concrete Paving Association. Before we get started, let me just run through a couple of very quick housekeeping details, and they are. We will actually be collecting questions and answering those questions offline at the end of or after our presentation, and then be responding to those questions by email. And as such, we do encourage you to type your questions into the question console, which you see highlighted here on your screen. You can type in those questions at any time. But again, those questions will be answered after our formal presentation today. Reason for that is we've got about 600 people on the line, so doing a live Q&A might be a little tough. If you have trouble seeing the presentation, you can minimize your console by toggling on or off that console using those double arrows that we're showing here. Be careful not to close the window, as that may disconnect your GoToWebinar connection. If you have sound issues, the culprit is usually the VoIP or Voice over Internet protocol. So if you are listening to this presentation through your computer speakers and you do experience any sound difficulties, we recommend that you switch over to the telephone mode. And that telephone mode, of course, is available through the audio feature on your console. So now, without further ado, I'm going to turn things over to Peter Taylor. And first, I'm going to transfer the presentation over. Okay, sorry for that brief delay.
Fantastic. Thanks very much, Bill, and I appreciate you providing the hardware for us to be able to do this session. So, to everybody online, welcome to the second in our series of 5 discussions about overlays. Basically, we're doing this as an opportunity for us to help provide some education and guidance, particularly for those who haven't seen this material before, and also to keep us awake and entertained while we are trapped in our homes. So, Gordon, if you can flip to the next slide. We want to thank the organizations that sponsor the CP Tech Center. We're not charging anybody for any of this material. We're doing it off the funds that we receive from PCA, Iowa Concrete Paving Association, Iowa DOT, and the American Concrete Paving Association. The other point to note is as part of the ACPA group, several of the individual chapters also provide funding for us. Speaking today, as Bill has already indicated, are myself acting as a moderator. Gordon Smith will do the bulk of the speaking, and Greg Dean from the Carolinas will be following up with a few worked examples of how some of these systems have worked out for us. Also, as Bill noted, with a very large crowd, it's kind of hard to do interactive questions. So feel free to write your questions in the questions box. We will collate those at the end and prepare a written document that will be emailed out to everybody after a few days. I think for last week's webinar, we finally got the final version out this morning after we had reviewed and edited it several times. Next slide. Some of the things that we were asked last week, some of the questions that seemed to pop up several times as we did a very quick and dirty overview of overlays, was how much traffic can these things carry? Or what about widened lanes? where can I get more information? And one of the questions that did come up pretty often, and that's what we're going to be talking about today, is how do I choose what sort of overlay I should be using for the situation that I'm in? And that's what Gordon is going to be addressing in the next few minutes. Next. For those of you who are wanting PDHs, everybody who is registered through the GoToMeeting system will receive a certificate saying that you had logged on to the system. And for some of you, the stated learning objectives are required, so these are what we've put up. They will be part of the slide set that you will also be receiving after the session is over. Next slide. As I said, we're in the second of 5 sessions. We will be recording all of these, posting them on the CPTech website. The first one is already up there. So today we're looking at evaluation of the existing pavement and how do you choose what sort of overlay you want to be working with for your situation. And with that, I think I am done. I'm going to hand it over to Gordon and let him take it away.
Good morning to everyone. I hope that you can hear me. And welcome also to the second session of the Concrete Pavement Overlay webinar series. Those who were able to join us last week listened as Dr. Taylor enlightened us with visions of why agencies and owners across the country are now very challenged to look at ways to preserve and extend the life of our pavement investments through careful consideration of things like cost, need, and resurfacing, rehabilitation alternatives. We also heard Dan King of the Iowa Concrete Pavement Association share one state story of their experiences in the advancement of the art and science of concrete overlays. Today, it is my pleasure to provide some further insight to concrete overlays and to offer some information about the process of selecting the right overlay for your pavement needs. I begin this session with a reminder that our webinars are a synopsis of the wealth of information that is found in the Guide to Concrete Overlays. This publication has been around for a number of years. The first edition was in 2007. We very quickly followed that with the second edition in 2008, adding managing traffic control issues into that version. And then in 2014, we had a major revision of the guide, which added synthetic fibers, an evaluation flow chart, which you'll see part of today, a geotextile interlayer section, information on 3D survey, stringless paving, and plate dowels. A lot of new information. And I'm very pleased to say that we have the privilege to currently be working in cooperation with the Federal Highway Administration to revise and to publish a 4th edition of the guide in the near future. This publication is a must-have resource for your venture into the world of concrete overlays. The CPTech Center also offers several other related publications that you might want to check out at cptechcenter.org. All, as Peter said, are at no cost to you for a download, and we would encourage you to take advantage of this wealth of resources. If you joined us last week, Peter described the system of concrete overlays based on needs, pavement condition, and design philosophy, from thin to thick, what is currently identified as bonded and unbonded overlays, as you see above. Today, we will delve into the nature of the overlays and look at the characteristics that are important in the overlay type selection process. We have a lot of conversation that's going on right now within the industry, and as we prepare to rewrite the guide and to redefine some things. And one of those conversations that's going on is really what is the meaning of bonded overlay and unbonded overlay? And do we need to retool how we are classifying that? I'm sure that's something that we'll be talking about, and we certainly appreciate any input that you might have. We got some questions about it last week, but primarily as we're looking at it today, the bonded overlay family is a family of solutions that could be applied to an existing pavement that has to be in good to fair condition. And from a design standpoint, there is the assumption that there will be bond and the old pavement is a part of the structure. The unbonded overlay family are a family of overlays that would be applied to an existing pavement that could be in poor condition. And the old pavement from a design standpoint is really just considered part of the base. So Will, it's a little bit hard to envision. You know, we have a lot of questions sometimes about, you know, how do you know whether you're bonded or not bonded? Again, it's really part of the design assumptions that the designer makes based on the pavements that he sees. And we'll talk about some of those conditions as we move along in today's presentation. Let's approach today by looking at the thinner overlays that are designed assuming bond and taking that into account in the overlay structural analysis. The first application that I want to share with some brief insight to is that of a thin concrete overlay on asphalt, assuming a bond in the structural analysis. The bonded concrete overlay of asphalt or composite pavement typically is anywhere from 3 to 6 inches thick. It's applied to a pavement that's in fair or better structural condition, as you can see on the charts to the left. The applications that we might consider for a bonded concrete overlay of asphalt or composite pavement is to eliminate the surface defects, such as rutting and shoving, to improve surface characteristics like friction, noise, and rideability, or to increase structural capacity where traffic loads have increased or will increase. I know we many times run into situations where there are changes in the use of a pavement and have had opportunities to go in and build overlays on those pavements in order to increase that structural capacity to withstand the loads that had never ever been anticipated in that situation. We've learned some things over the years with regard to bonded over asphalt or composite pavements. We call them keys to success. What we know is bonding is critical from the standpoint of our assumption in the design. If we're not sure that it's going to get bond, you're probably going to design it as an unbonded overlay. And it may bond, but you're just going to get some benefit from that. Sometimes the bonded overlays have been used because of our desire to get thinner for the application that we have. They may not last as long, depending upon the traffic service. Bonded overlays need small square panels to reduce curling and warping and shear stresses in the bond. The jointing is usually 1.5 times the thickness. I was looking at that this morning. I'm thinking, that doesn't really say what we want to say, but that's how we always refer to it. But basically what we're talking about is take the thickness, for instance, of 4 inches, take that times 1.5 times, and then our spacing for joints in that situation would be a 6-foot spacing. Oftentimes we need to mill and to remove surface distresses to improve the bond or to remove the surface distresses, excuse me. This is probably more critical in the bonded or thinner overlays than it is in the thicker overlays, in the fact that we need to have a surface that has some consistency in it so that we can control the thickness. When we get into the thinner pavements, a 10% decrease in thickness is a lot more substantial structurally than a 10% decrease in a thicker pavement. We have a recommendation to leave 3 inches of asphalt after milling. I know that's another topic that's going to be discussed as we put the new version of the guide together. This was a conservative estimate that was made in part because some of the conditions that we see these pavements that are in, when we pave on them, we've got to oftentimes have a platform from which to work on with the construction operation. And we found that if we get into considerably thinner pavements than 3 inches, that we sometimes, depending upon the base that they're sitting on, would run into problems with those construction activities or the support of that. Not to say that there aren't situations around the country, and we're aware of some, where we've had very strong sub bases and bases underneath the pavement, had a thin asphalt overlay, and quite successfully were able to use a bonded or an unbonded overlay on top of those thinner asphalt. But primarily here, it was to look at some of the issues that we had seen in construction. The HMA surface temperature should be below 120 degrees before paving, so we don't have a tendency to rob some of the water out of the concrete as it is curing. Joints in the overlay should not be placed in wheel paths if possible. And as with all overlays, especially the thinner ones, an application of curing compound is critical. This is a photo of a project that I just wanted to share with you. It's Wadsworth Boulevard near C470 on the southwest side of Metro Denver. It was constructed in 2001. It actually was the 6x6x6, 6 inches thick, and 6x6 panels that you'll hear about and see in the guide as maybe one of the kind of standard things that we're doing today with the thinner overlays. It has a bonded design, or it was designed as a bonded overlay. And down in the lower right-hand corner, you can see the condition according to Google Maps, or Google, whatever it is, so that we see that condition in 2019 and it is performing quite well. Let's move on to the unbonded concrete overlay of asphalt, or the composite pavement, shifting our focus a little bit. The unbonded overlay would oftentimes be a thicker overlay because it's more of a new pavement on top of an existing. It could be 4 inches thick, depending upon your design and the traffic needs and the intention of how long that rehabilitation method should last. The existing pavement, in the case of the unbonded overlays, can be in a little worse condition. You could have severe rutting, potholes, and alligator cracking, even some shoving and pumping. But what you're really looking for is stability and uniformity in that base so that you can depend upon it for a foundation course for that overlay. The applications that we see for unbonded overlay of asphalt are to restore or enhance a pavement's structural capacity, to increase the life of the pavement equivalent to a full depth pavement, to eliminate deterioration problems, and to reduce the urban heat island effect by increasing pavement surface albedo, something that's becoming important as we work with some of the municipalities, especially around the country. What are the keys that we've learned from our work with unbonded overlays or asphalt or composite? We'd like to encourage milling to eliminate the surface distortions if they're more than 2 inches. A little differently than what we were dealing with the bonded overlay. We're dealing there, probably could not take 2 inches, but we want to try and still mill that surface down so they don't have major distortions. Complete repairs at isolated spots, obviously we'll have to do some of that where we have issues with structural integrity of the pavement that needs to be restored. Concrete patches should be applied to the existing pavement, and they should be separated from the overlay. One of the things we've run into sometimes with the concrete patches, and when we're really working with what we call an unbonded overlay, is if we get a good hard bond against the concrete surface, it may not move with the rest of the pavement mass that would be on top of an asphalt. So oftentimes we'll use a seal coat or even fabric. Sometimes we've used that to kind of break that bond between those patches and so that it will move consistently with the rest of the slab. Surface temperature, again, should be about 120 degrees or below when placing the overlay. It should be below 120 degrees. And partial bonding between the overlay and the existing asphalt pavement is acceptable and may even improve the load carrying capacity, although you're not necessarily depending upon that in your design process. Here you can see one of the pavements in the historical files that we overlaid some years ago. Certainly can be fairly poor condition on that asphalt pavement, and you can see in the right-hand lower corner the overlay after it had been serving for several years. Here's an example of a project that was on a runway, 1230 at Renner Field in Goodland, Kansas. That runway was constructed in 1974. It was 8 inches thick. It was an unbonded overlay on asphalt, and you see in the photo the condition of that pavement in 2014. So certainly it has performed to the expectation of the designers or beyond. Now we're going to move into a little discussion about the overlays on concrete pavement. And first talking about the bonded concrete overlay of concrete pavement. It consists of a thin concrete layer on top of an existing concrete surface. And we take specific steps such as milling or sandblasting or water blasting to assure the bond of the new concrete overlay to the existing concrete. Bond is equal to strength, and it's very important because this is really a monolithic slab as it is built and performs. The typical thicknesses for these bonded concrete overlays of concrete pavement have been 2 to 5 inches, and again, the condition of the existing pavement must be in good to excellent condition before you would really be able to consider the bonded option. Some of the things that we've learned in bonded overlay on concrete, the bond is essential. Concrete aggregate used in the overlay should have a thermal property similar to that of the existing pavement. If we put a gravel on top of a limestone or vice versa, sometimes with a significant difference in the coefficient of thermal expansion, what we'll find is that those pavements work against one another and sometimes would result in debonding or some type of other deterioration in that pavement. With bonded concrete on concrete, the joints with the underlying pavement allow the structure to move monolithic. So it's very important in this design that the existing joints must be in fair condition or be repaired. Timing of the saw joint is important, and we typically recommend that we cut transverse joints the full depth of the overlay plus a ½ inch down into the existing joint to make sure that we have prevent issues with bonding and expansion of those pavements. Longitudinal joints are typically T/2 or the thickness over 2. The width of the transverse joint of the overlay should be equal to or greater than the underlying crack width of the pavement. That's so that if the underlying pavement expands and the overlay pavement has a narrower joint width, as that underlying pavement expands monolithically, you're going to start to get point bearing on that overlay if it closes up. It may not be closed up on the bottom, but certainly could be on the top in the overlay if the joint is not wide enough. And that would oftentimes result in issues of debonding in those areas or other types of joint deterioration. Curing, again, should be timely and adequate, primarily in these bonded overlays, whether it's the thin bonded on asphalt or on concrete. The reason that the curing is so important is because you're dealing with usually a relatively thin pavement. And the hydration process needs to be assured in those pavements so that we can be sure that we get the proper strength and even the proper bonding in those types of installations. Finally, in the first section here this morning, I want to talk just a bit about unbonded concrete overlays of concrete pavements. It's our final application today, and then we'll get into some of the selection processes. Unbonded concrete of concrete pavement is 4 to 11 inches. Typically, it's used when existing pavement is in poor condition, including materials related to stress such as decracking. We can and have built pavements overlays on top of material related to stress, ASR or decracking. I think when we go into that, we want to be sure that we understand what the condition of that decracker is and how long it might perform as the base for the pavement. We have seen, I was involved with an overlay in Iowa many years ago on Interstate 80 out in the western part of the state, where we built a 3-inch bonded overlay on a fairly badly decracked pavement. The DOT was trying that as an option to see if we could do concrete overlays. And like many DOTs, we did do that. The bonded was not probably the best selection in that case, although it did last for 11 years. The DOT thought it might last for 5. And when they tore it out, the only thing that was left of that pavement structurally was the overlay itself. But when we're doing the unbonded overlays, we have a little more leniency in the utilization of that as a base. And as long as it doesn't completely go to pieces on us, it will work as an overlay. And we've seen instances here and other parts of the country where these overlays on some of the decrackers would probably last for 15 to 20 years at least, sometimes more than the original pavement did. This pavement and the sub-base should be stable and uniform, except for the isolated areas that we might have to repair. It's used typically to restore structural capacity of the existing pavement and increase pavement life to full depth pavement. What have we learned about unbonded overlays on concrete? Full depth repairs are important and should only be where structural integrity is lost at isolated spots. One needs to monitor that to some extent, because if you find that you have to do too much patching, it may not be the best approach for rehabilitation. The separator layer that Peter mentioned last week is normally 1-inch asphalt or geotextile fabric. The overlay is used to restore structural capacity of the existing pavement and increase the pavement life equivalent to full depth pavement. We try to suggest that we have faulting that would be 3/8 inch or less in the existing concrete, so we don't get a keying action between the unbonded overlay and the pavement, that concrete pavement that we're laying the overlay on. If it is more than that, you might have to do some milling at those joints, or in the worst case scenario, you could also look at the possibility of doing the asphalt interlayer, which gives you a little more flexibility in that regard. It's not necessary or recommended to match joints with those of the underlying concrete pavements when we're building these unbonded designs. Peter showed last week the asphalt separation layer that we often have seen in the past as a stress relief course, as a bond breaker, and now today we see more and more utilization of the non-woven geotextile fabrics, because they do add some value to the project for the contractor in being able to have a control of that operation and be able to get that done in a timely manner. Here's just a few pictures of an overlay candidate that we looked at around the country, and to show you some of the severity of pavements with regard to decracking that you might see here, and the fact that they were, with some joint repair work, considered a valid candidate, and were overlaid and are working quite well today. Here's what we oftentimes do with preparation on those, is to remove the loose material and debris. We place a cement-based flowable fill or other type of filler in those deteriorated areas so that we avoid the keying action and make sure that we've got a fairly smooth surface to overlay on. This is a project that was constructed on Interstate 86 near Olean, New York in 2004. It was a 9-inch thick unbonded overlay, obviously on the interstate, looking for more traffic, as we would see in many of those applications. It had a HMA interlayer, and the picture that you're actually seeing is the condition of that pavement in 2019. So after 15 years, it's still doing considerably well as a rehabilitation or resurfacing option. It's important that our Pavement solutions, whether they're concrete, restoration, rehabilitation, concrete overlays, full depth replacement, maybe even an asphalt alternative, are appropriate for the identified need and the condition of the candidate pavement. This now will be our focus of the discussion as we walk through some of the information that's contained in the guide with regard to project evaluation and selection. We saw this last week, but I probably should repeat the fact that asset management involves a strategic and systematic approach to managing pavements. It relies very heavily on pavement management data and life cycle cost analysis. Pavement management and pavement preservation activities have become extremely important in managing and accounting for investments in highway pavements or airport pavements. Over the last decade, the Federal Highway Administration has been a strong advocate of the concept of cost-effectively preserving the country's roadways. And that's part of the challenge that we all face today as we look at how we're going to take care of our pavements in the future. As you can see on this graph that we have pavement preservation up at the top and the types of things that we might be doing on that, and where we feel that the overlays typically fall is in that major or in the minor rehabilitation below the some preventive maintenance sometimes, especially if you're doing a bonded overlay to increase structural capacity. But we just wanted to remind you that this is how some of these decisions should be based, is on your pavement management information. Okay, consider the answers to these questions that ultimately determine the answer to a much bigger question. You know, the design objectives. You know, what kind of a pavement life do you want for this improvement? We've had instances where people have gone in and done an overlay on a pavement with the intent that they only needed 15 years because they figured they were going to come back in and reconstruct that pavement down the road. Or they may want to make sure they're optimizing the life of that pavement with respect to the cost to be sure they can get as much out of it as they possibly can. Need to understand also the desired level of service. What type of traffic and what are you going to have on this pavement and how that will be reflected in the design. And also the condition of the existing pavement. We'll talk more about that as we move along. And budget objectives will also have an impact on your selection process. Hopefully, if we've answered those, then the big question becomes what overlay option will achieve these objectives. Pavement evaluation probably doesn't have to be anywhere near as serious as these guys had gotten, but it is important. Concrete overlays require relatively uniform support conditions. Unbonded overlays are less sensitive to uniformity, and stiff support conditions lead to little or no slab defections. Premature overlay failure oftentimes has been traced to choosing the wrong project or choosing the wrong option. The evaluation of the existing pavement is paramount to determine if adequate support and movement control exists, or if it can be achieved cost effectively. And we know that that has to be a part of the question today. Questions that you might also consider. Will a bonded concrete overlay act as a monolithic unit with the underlying pavement? Is that going to be good? Or does the underlying pavement have cracks in it that you don't want reflected up into the overlay? If you choose a bonded overlay, they will reflect. Or will an unbonded overlay, giving you a little more feasibility, be necessary to meet the same criteria, but with the added burden of meeting critical elevation constraints? Sometimes we run into elevation constraints and may have to design our overlays differently in order to be able to meet those restraints. To have a successful overlay, the good and the poor characteristics of the existing pavement must certainly be understood. A site visit or field review is a critical step in the pavement evaluation process. What are we going to do out there? We're going to try and document the existing pavement conditions, pick up information for the necessary design inputs, either for the engineer or for the designer, and to identify any of those field constraints that we mentioned earlier. So the first step is to look at pavement history, followed by reviewing the field review of distresses, coring of the pavement itself if needed, not always essential, field tests where necessary, and a condition assessment of the pavement profile. When we talk about pavement history, there are a number of things that we need to consider. I don't think I'll read all those. Hopefully you can see them, but certainly mixture materials. What's the history on the mixture materials? If there's asphalt involved, if we're overlaying asphalt, we would maybe want to understand the history or the nature of the lifts in that as to whether they would be suitable to carry this overlay. Pavement management records will be important, and also, as we mentioned earlier, understanding what the desired design life was and will be for the overlay. In the manual, there's some great visuals of that should help you a little bit to identify the condition of the pavement that you're looking at. When you're out in the field, you want to identify the distress, the type of deterioration, the amount of deterioration, and the severity of it. As you can see in the photos, we start with the good at the top, whether they're concrete pavements or asphalt and composite pavements. As we move down through the matrix, we see fair where we have a few cracks, poor condition where we get some crossing cracks, and then certainly what we would probably call as a deteriorated pavement. All could be candidates, but we would have to choose our overlay based on what we have in those pavements. We want to evaluate the uniformity of the distress conditions. Are there any clues to what might be going on, or is there just some isolated stuff that we need to address? We might identify areas for further testing and evaluation in that process. And while we're out there, we probably need to document the repair quantities so that we have some idea and can compare that to what our budget is and some of the conditions that we face there. Pavement evaluation data elements would include the pavement condition, the pavement thickness, support condition, materials and soil properties, traffic volumes and loadings, and the climatic conditions, plus the drainage conditions, which could have an impact on which overlay we use and how we're going to use that. Unfortunately, we don't have this. This is a part of a one-day workshop, and we can't get into all the detail, but hopefully we're giving you enough background on it so that you might inquire with others that have done the overlays. You'll be hearing about more and more of that throughout the series, and also to look at the guide and try to answer some of your questions through that avenue. Other project factors that might be considered are project geometry, the vertical restrictions. Sometimes with regard to project geometry, we run into situations where we may have to change the super elevations in the overlay itself when we're putting it on there. So you need to understand what the impact of that would be as far as increased concrete or something of that nature. Vertical restrictions could be bridges, curb and gutter, cross streets, utilities. Peter mentioned that last week. Existing grade and cross slopes that are coming into the project, shoulders and ditches. It's important if you're in rural areas that you've got some pad line for your paving machine. That oftentimes is a challenge in itself and certainly needs to be considered in the design process. From the distress survey, you're going to answer these questions. Does the pavement condition or distress lend itself to a PC overlay solution? And if it does, then what pre-overlay repair or type and amount may be required? And are there other project factors that should be considered, and what additional field testing might be required? We could go to core analysis, certainly not to the extent that you see in the bottom right-hand corner, but sometimes it's good to go out and take a couple cores of the existing pavement so that you can verify the thickness and the condition of that pavement before you really make assumptions about the type of of structural contribution that it might make, or its ability to hold up the overlay itself. Coring would be looking at layer conformation, layer thicknesses, variability, subsurface conditions, whether there's stripping or delaminations going on in that asphalt, if you're working on an asphalt pavement. And then you might want to do some samples for lab testing later on. I talk about this stuff, but I want to offer the caveat that there are a lot of overlays that have been built that have not had a significant amount of testing done on them. And I think we have to be very careful about how much of that we require or do. We've got a sense of how the roadway's working. We know what's happened in the past as far as the performance is concerned. So we're learning more and more about that. And I think that actually will help us understand better when we might need to do more testing and when we probably don't need to do that. Rarely, you might run into looking at some of the distress and type, severity, amount of roadway drives that drives the need for an amount of field testing. And the bonded systems, as we mentioned, will require more detailed and thorough field analysis. Again, in the book, there's some optional analyses that are listed that give you some ideas of things that you might consider in the process. Evaluation is also used to determine whether required repairs might be needed, develop the thickness design inputs, and when combined with an overlay, you want to know that the existing pavement can help carry the anticipated traffic either as an integral part of the pavement in the bonded or serve as a base or sub-base in the unbonded category. Once we have done that evaluation work, it's important to record the pertinent information from the long list of conditions that might affect the design, constructability, and performance of the overlay. Now I'd like to walk through just the condition things, some of the selection aids that are involved in the guide, just to give you a feel for how you might utilize that. Again, we're going to look first at the overlay selection for existing asphalt pavements, recognizing that we have fair condition pavements. You can see the pictorials on the right-hand side to give you a sense of what you might see in that type of a condition. Poor condition, these would line up somewhat with those actual photos that I showed you a little bit earlier. Deteriorated condition of course will exhibit very poor conditions. But it gives you just a pictorial of that, and then you can move into some of the decision making. If you want to do overlay selection, for instance, for an existing asphalt or composite pavement in good to fair condition, you want to look at the pavement to make sure that it's structurally sound, but it may have some surface distresses, potholes, and block cracking. The pre-overlay question which we pose is, can milling and minor spot repairs cost effectively solve those deficiencies and bring the pavement up to good condition and meet other constraints that you might have on the job, like the vertical clearance and those that I mentioned? If you can do that, it's a candidate for a bonded overlay. If not, you're going to have to look at a different type of rehabilitation, or sometimes may move into actual reconstruction. But if you can do those repairs, if you can meet that good condition, you can certainly do the bonded overlay on the asphalt or composite and move into the shorter joint spacings as we talked about. Here's an example of an overlay selection for existing asphalt or composite pavement in poor to deteriorated condition. The question here is, can milling and or structural repairs cost effectively solve the deficiencies, bring the existing pavement to condition that will provide uniform support? If not, you have to look for other options. If it would, unbonded concrete overlay will probably be your best approach. Similarly, on the concrete side, we have the guidance there as to the condition of the pavement from fair to deteriorated condition. And we start to look at the selections for existing concrete pavements in good to fair condition, where you have a structurally sound pavement but very minor surface distresses. The question is, can we spot surface repairs or spot structural repairs cost effectively to solve the deficiencies? Again, if we can't, we look to the other alternatives. But if we can, it's certainly it's a candidate for a bonded overlay, and you can move forward with that. So it just gives you some guidance as to the types of things that you might want to consider. And I'm sure as you get into the more and more use of overlays, you would probably build that list a little bit with regard to some of those questions. Here is an overlay selection for existing concrete and pavements in poor to fair condition. Again, the question, can milling or structural repairs retrofit subdrains, maybe slab stabilization? Can those things cost effectively provide the uniform base that you need for this repair or rehabilitation? If not, might have to look at other overlay options, or certainly sometimes the rehabilitation or reconstruction might be involved. If you can meet those conditions, it certainly would be a candidate for an unbonded overlay on concrete. Just a couple precautionary things. There's several of those throughout the guide, but we do caution users about the minimization of the milling, sometimes to retain that structural support of the pavement. This is a condition that we ran where we had a relatively thin layer of asphalt still existing, and you can see what happened in this case because of some of the construction traffic that ran on it and created an issue for us. We had to do some repair on that prior to we could pave on it. It's preferable to mill to a depth that will minimize that potential. And you do sometimes need to make some grade corrections, and we understand that, but again, make sure that you know how much thickness you've got down there in that pavement. We already talked a little bit about materials related to stress, and I just say that, again, we do have done some overlays on that. They typically will not last probably as long as a material that had no aggregate issues in it or reactive issues in it, but if you're looking for a 15 to 20 year fix, I think you can certainly design an overlay that will work in many of those cases. So with that, I've kind of covered what I needed to do today or wanted to do with you today. I'm now going to turn it back to Bill, and he's going to get Greg Dean hooked up, and we'll hear about some of the overlays from the Carolinas. Greg called me last week. I have to tell you this, and I forgot to put the picture in here, but we had a map last week, and the Carolinas were, one of the Carolinas was obviously missing as one of the states that had done overlays, and we've revised that map. That's one of the joys of doing webinars. You can ask questions, you can make comments, we can make changes, because we revised that map last week to make sure that we did show that both of the Carolinas have done webinars, along with some of the other Eastern Seaboard states that we were able to add. So kudos to Greg and the work that he's done out there. So Bill, take it away.
Oh, thank you, Greg, or thank you, Gordon. And Greg, I see your slide is at the ready, so take it away.
Wonderful. Greetings from Raleigh, North Carolina. We have a very beautiful day out there. I think the last time I looked, it was about 65 degrees. So those that are up there and still in the Midwest cold, don't dislike me too much, but we'll try to send you some nice weather. I'm real pleased to be able to participate today, kind of give you the Carolinas story, the Carolinas experience. Of course, last week, but for those that were on, heard some of the great work they're doing up in Iowa, some of the wonderful performance. So I hope to, again, just kind of share what we've been doing in the Carolinas. I think you'll see some pretty remarkable achievements. I think some of the overlay work we've completed has been done very well and received well by our owners and agencies. There on the slide, you'll see the Carolinas Concrete Pavement Association logo. As Peter was saying, we're one of the Carolinas Concrete Pavement Association is under the umbrella of one of the 20 affiliated chapters. In this case, it's the Southeast chapter of ACPA. I've been with the association with the ACPA Southeast since 1993. It kind of gives you an idea of my history with the in the concrete paving industry. So I have seen some of these overlays from the very beginning. My focus since 2013 has been strictly the Carolinas. So it was narrowed from 6-7 state areas down to just the Carolinas in 2013. So that's what that's really what I'm going to talk about today, is just the Carolinas, although we certainly have had some overlays beyond the Carolinas borders and other parts of the Southeast. Trying to get it to the next slide. It looks like it's a little sticky and slow. Yeah, it's a little slow, Bill, but hopefully it'll warm up or something. There we go. Now, hopefully it won't advance again. But anyway, this is the slide that was used a couple times last week, and I know if you were a participant, you went, wow, there's a lot of overlays being done there in the Midwest, and not so much out west or along the eastern seaboard. Certainly the Carolinas have a few bubbles there, and I'll take full responsibility. We're kind of the ones that input these jobs, and I'm going to be talking about a couple jobs that probably aren't even inputted, put into the Explorer, something I've got to work on. So, but again, first glance, you go, well, maybe the Carolinas really do not have a lot of experience with overlays, and that's really not true, as you'll come to learn. Let me see if my advancement will work a little better this time. Yay, doing good. So I thought this slide would be good just for a good quick glance. So where are the experiences? What kind of overlays have we constructed here in the Carolinas? So I broke it down between North Carolina, South Carolina, the various overlays like what Gordon was talking about. You have bonded on asphalt all the way through unbonded on concrete in each of the two states. As one of the slides shows, as you do unbonded, naturally those are designed a little thicker than the bonded ones, can be quite a bit thicker than the bonded ones. As you can see by market segments, we've actually have done quite a few overlays in the airport market that I kind of won't be talking about today. I think most of the audience members out there from the first session appeared to be more DOT agencies, local municipalities, so I'm going to stay away from that in this talk because of brevity of time. I love talking about airport overlays though, and maybe that's something we'll do in a future webinar session, but it's kind of a market all to itself, a lot of different factors and how it's approached, so that should be kind of held separately. But what I do want to spend time is talking a little bit about our highway projects and what I call local roads projects. And the first thing I want to point out, in North Carolina NCDOT and South Carolina DOT, we have a very large maintained system. North Carolina being the second largest, and South Carolina being being the fourth largest state maintained system. So why I bring that forward is some of the road network that's on the DOT maintained system in our states would probably and could very well be like a county road, like what you were hearing in Iowa last week, and maybe a city road. But so we have a very large maintained system that both of our DOTs are responsible for. So in some cases, I was having a little hard time. Do I count that as a highway job, or is that a street and local road job? But anyway, it still works out either way. So that's the purpose of me kind of drawing those errors, that we do have a lot of overlap there that maybe doesn't occur in some of our other states beyond the Carolinas. But you can see here, a lot of our blocks or a lot of our boxes are checked. We do have a lot of overlay experience in the various categories. So the next thing I wanted to kind of share, and again, kind of gives you a really good timeline as far as, well, how long have they been doing overlays? And I'm going to be definitely sharing a couple projects here. I'll go into a little bit more detail. Can't get into a lot just again because of the time factor. But what this illustrates here is, for the last 20 years, we've been kind of doing overlays, or actually a little bit beyond 20 years. As you can see here on the bottom left, and again, my arrow's a little sticky, so I'm not going to try to use that. It kind of clogs me up. So, but there on the bottom left, you can actually see that NCDOT let their first unbonded overlay of concrete, again, putting concrete with a separation layer over top of old concrete, in this case, old continuous reinforced concrete pavement on projects in Granville, Vance counties, I-85. They actually bid 4 projects starting in 1997 all the way to 2007. In the same time period, SCDOT let their first unbonded overlay on concrete. Again, this was an old jointed plain concrete pavement, no dowels, it had a lot of faulting, a lot of slabs that had been repaired in prior projects. But again, so they let their first project around 2000. So you can see, again, now we're starting to get quite a bit of good performance, or at least you can go back and look and see how are these projects performing. As a matter of fact, our pavement management group there in North Carolina has participated in our workshop on a couple different occasions, our state workshop, just kind of given that performance history. And I'm sure if anyone's interested out there, they would be happy to share either their presentation. I think they even gave a TRB paper back in like 2007, or maybe it was, I can't even remember. I think it's 2007. They even presented up a TRB on the performance of some of their early concrete overlays. So again, this timeline gives you a sense of the type of overlays we've done. Again, South Carolina's first intersection there in Conway. We actually did some ultra thin white toppings that, again, those are kind of the bonded ones that I'm not showing on this timeline. Just it was just starting to make my timeline look a little too clogged up. So I left some of those early projects out, but we started developing some history. You can see some of the FAA funded projects. Those are our airport jobs. And now if you look to the right, we've actually have completed 8 local airports with runways unbonded over top of old asphalt, distressed asphalt. So you can see we're getting a good history of concrete overlay use. The ones that I put in the blocks, the little purple block, those are the projects I'm going to kind of hit upon again very quickly today. I would like to mention that we've got some good large projects under the design build that's currently underway. Not all of those big square yards, $1.5 million in one, $1 million in the other that SCDOT is currently doing. Not all of those jobs are complete overlays. In some places you're widening, in some places you're doing some cuts and removing the pavement structure, but a good portion of these jobs actually are putting the concrete directly on top of the asphalt. So we're getting, again, some good sizable work here in the Carolinas. So let's look at this first job. It's SCDOT. It's old. It was an old U.S. route. It had been turned into the interstate, into a interstate designation, I think in the mid 1980s. It's probably the least busiest interstate in our state, and made a very good candidate from both an overlay standpoint. But the biggest thing, it made a very good candidate from the standpoint we can handle the traffic. There was a detour, as you can see here on this picture. There was a detour that would not allow traffic coming from the Columbia area to Greenville. It totally eliminated all of that northbound traffic and made them stay on I-26 instead of turning off on 385. That detour was about a 20-minute detour, and it kept that northbound lane shut down during the entire construction. So they allowed southbound traffic on one side while they were working on the other type thing. This was a pretty sizable project, 14 center lane miles, again, putting the concrete on top of the asphalt. They milled 6 inches of the existing asphalt and came back with 10 inches of jointed plain concrete pavement with dowels. And the contractor actually had a choice of using a Portland cement concrete pavement shoulder or an RCC shoulder. He could bid it either way. And in this particular job, RCC was more cost competitive, or was a little less, I think 20% less, and that's the way the contractor elected to go, with an RCC shoulder. And there's the RCC shoulder in this photo here, 8 feet. As you can tell, they used a widened lane. I think I saw on one of the earlier slides, someone asked the question, can you use widened lanes with your overlays? And you certainly can. You just got to make sure you have good support underneath. Because of the crown shifting in this pavement, we actually, the contractor actually had to build some asphalt out along the edges of both sides. I think about 4 inches of asphalt was added to the existing structure on both sides to provide that good uniform support for the eventual overlay, as well as that RCC shoulder. Of course, all the construction met the Green Book standards. and that was part of the reasons, one of the reasons why we needed to shift that crown. I guess the key thing I wanted to share with this thing is how fast overlays can be constructed. By shutting down that one side and giving the contractor complete access to the other side, as you can see here, the construction for this 14-mile job commenced on January the 2nd in 2010, and the ribbon cutting took place 202 days later in July. So that illustrates how fast these overlays can be constructed. I didn't touch upon, or forgot to touch upon, the fact that the concrete strength was increased because they didn't want to increase the grade more than 4 inches. So the concrete strength that was normally 4,000 in the state of South Carolina was increased to 5,200, which kept that overlay thickness down to 10 inches. So there's things like that you can do to minimize that grade elevation change. The next project I wanted to discuss, this is an NCDOT project. And again, another outstanding project. Matter of fact, it won an ACPA award in 2009 in the overlay category. The main thing I wanted to kind of hit upon there is just, again, maintenance of traffic. They actually put in temporary asphalt in the median that carried traffic eventually in both directions to facilitate the movement of traffic while during this construction. Again, gave the contractor that opportunity to pave full width, 24-foot wide. So this was an 11-inch overlay with like an 1.5 inches, I think, minimum bond breaker, an asphalt material used over top. In this case, this was, again, a CRC pavement, very similar to the work that they had done on I-85 in prior years. So this was a 2007 construction. I think it actually, of course, went in 2008. And again, outstanding example of concrete overlays use. One of the things, again, the challenges of some of these jobs, not all of them, and sometimes not throughout the project, but again, because this was in the foothills region of our state, it's a very environmentally sensitive area. Had to be careful with those shoulders and to avoid making sure we have the correct slopes outside the shoulders and avoid sliver fills. We had to put in this thing called like a sub slab, where you're actually, again, similar to that project I showed you earlier on 385, we had to actually build some support out on the edge, inside edge, to shift that crown point. And it worked well. Again, provided that's what those pictures illustrate, is just the construction of that sub slab, so that then the separation layer could go on top of that, and then the 11 inches of concrete. But again, that project worked out real well. We've had several of our projects highlighted in the Concrete Pavement Progress. Hopefully y'all have seen this magazine. If not, I've kind of provided some links there along those edges that I'm not sure if those links are going to work when they come to a PDF, but anyone that gets the PowerPoint version, you can click on that and actually get a copy of these Concrete Pavement Progress magazine. As I mentioned earlier, a lot of these projects have been ACPA award winners. The project there on the left was a recent overlay of an airport, won the award this past year, and then the photo there in the bottom there, that's the I-77 Yadkin County project that Lane Construction NCDOT was recognized back in 2009. So again, these magazines do a great job of capturing the essence that I'm not able to really share the complete story today, but I would encourage you to look at that magazine if you can, to see some of these stories. The next project is the I-85 Vance County project. And again, if you remember my timeline that I shared earlier, that's been one of our more recent jobs. The reason why I wanted to highlight this one, and again, this session being put on by the CP Tech Center, this is a perfect example of what Gordon was saying. You know, by making those site visits, it really can pay dividends. In this case, NCDOT brought the CP Tech team in for training. I think it was like a day's worth of seminars or presentations, and then actual field visits. So we were able to see some of these things. And we went out and looked at this, the asphalt ultra thin bonded wearing course that had been placed over top of our 1960s 9-inch jointed plain concrete pavement. That was done in 2007. And so the big question NCDOT had during this time was how much of these existing patches needed to be repaired. And so you can kind of read here for yourself. the outcome. They did some good testing, you know, looking at, they did some GPR, looking at some falling weight deflection. And in the end, the decision was, hey, you know, we can leave this ultra thin bonded wearing course there, just use our separation layer over top of it, leave most of those patches did not require replacement whatsoever. And in the end, they estimated by doing that, resulted in just in pre-overlay savings of about $8 million. So again, I wanted to recognize what the CP Tech Center is capable of doing in providing that assistance. A few project highlights there, and again, you can see the link, the Southeast Cement Promotion Association, that I kind of forgot to recognize in my opening, but we do a lot of partnering work with the Southeast Cement Promotion Association, as well as our Ready Mix Association. They provide a lot of the ready mix on some of these projects, so we do a lot of collaborative work with them. There's actually a project spotlight on their website for those that like to learn a little bit more about this particular job. But this was an over 20-mile job, 661,000 square yards of new jointed plain concrete pavement that was placed. And obviously with these overlays, I get all excited about the concrete pavement portion, but every job has a lot more work beyond the concrete placement. You know, my contractors will sometimes kid me and say that, you know, that's when you get to the concrete, that's the easy part. It's all this other work that takes a lot of more coordination and requires the more intense effort. One of the cool things about this job that I wanted to highlight, they did after the project was bid, they wanted to accelerate the schedule. As you can see here, the traffic was put in a one side head-to-head direction. They didn't want to have that in that scenario any longer than needed. And boy, you can really take a look at that photo there on the left, on your left, and see how the percentage of truck traffic. I mean, I can't remember the exact ADT through here. I think I've got it written down somewhere, but a lot of trucks, you can see that. But they were able to pave one complete side in the year 2017 with this accelerated schedule, which enabled 1 year earlier completion. So again, this illustrates, you know, with a lot of coordination and you know, good partnering between the contractor and the DOT, you can really move the work along well. So I've covered a lot of unbonded overlay stuff, unbonded on asphalt, unbonded on concrete. Those are I guess you would say, our big users. But as Gordon was saying, I think there's some opportunities for bonded overlays of asphalt. The bonded overlay of asphalt job that we've had here in North Carolina, and again, I just don't have the time to share the work they've done down in South Carolina, but this one, these pictures, I think, kind of show what you're capable of doing. This interchange down in near Gastonia, North Carolina. This is south of our Charlotte area on I-85, very heavily traveled interstate, of course. The interchange there, the on and exit ramps were rutting. It was kind of a periodic maintenance thing where they were constantly out there milling and filling. So the division engineer at the time said, hey, you know, I would like to see some concrete here, and he was willing to look at doing a bonded overlay of asphalt. So in this case, just to ensure they had enough asphalt base underneath that concrete overlay, they you know, did add some asphalt. And again, this project, I ride through here and I look at it and it's still performing very well. And again, one of the key ways you can determine that you're on a bonded overlay of asphalt is these small panel sizes. I think out there they were close to 6x6s. So one of the last markets I wanted to share with you is the fact that we have had some success with a concrete overlay in even a local street community. This is a community outside of Chapel Hill, North Carolina, called Governor's Club. They're currently out there working, probably today, matter of fact. It's such a beautiful day, but they've had ongoing work of replacing their concrete. Some of these streets date back to 19 or 30 years ago, whatever time that period would be, in the what would be early 80s or something. And some of these streets just were designed little uneven support. The joining practices weren't the best at the time, so they wanted to keep their concrete heritage. They really liked their concrete. It's just that it would needed some attention. So this community is putting that geotextile fabric down in lieu of the asphalt separation that we've seen in other projects. This is one of our first experiences with geotextile as the separation layer, and it seems to be working real well. All of these projects that I've been sharing today It's all about traffic management, and in this case, this was a device that used that bottom picture there. It's just one of those devices that they used to help manage the traffic in the places where they couldn't pave full width. In some places, because there was only one way in and one way out, cul-de-sac type streets or streets that just only had one access point, they actually used devices like this. They were on timers where the traffic had 2 minutes to move through the construction zone during the construction as well as the curing of the concrete, and it seemed to work real well. In many places, they were able to pave 24-foot wide and plan to continue to do that where they can, again, have the place to move the traffic off. So this was, again, another example of unbonded overlay of concrete, and a spotlight is on that website. So in conclusion, this is my summary slide. I think our agencies would agree with me that our unbonded concrete overlays of both, especially the concrete, but also the asphalt, have performed very well. I think one of the things I've heard from our local airports that it's enhanced competition on projects. They certainly have seen better performance. When you put down asphalt over top of cracked asphalt on these runways, you get reflective cracking fairly quick. For every inch you put down, you get reflective cracking about in 1 year for every inch. So what they're finding with concrete, you don't get that. I say the keys to success, and I kind of hit this on a lot of my slides. It's all about the maintenance of traffic. Providing that access, at least in one direction, is ideal. It enables a much better production and quality. Stringless paving was mentioned last week. A lot of our jobs have utilized that. One of the other changes that we've done since some of our early jobs, we've gone to a uniform 15-foot joint spacing versus the old variable 18 to 22. And it seems on some of those longer panels where we had some mid-panel cracks, it has definitely alleviated that. So good uniform joint spacings. So one of the things I'd like to see is our state and local agencies to try this bonded overlay of asphalt more. Like I said, the job there on that ramp seems to be performing well. We know some states that you'll probably hear more and more about through these webinars are using the 6x6 overlay technology. So I hope to see some of our states begin to look at that technology as well, bonded on top of asphalt. I do think the more I look at some of the resiliency issues, I think there are some benefit of putting concrete overlays in areas to pavements that are exposed to flood water inundation. There's already some reports out there that indicate when you use a concrete hardened system, you can improve and lessen that pavement deterioration curve. So with that, I think that's my summary, and I appreciate y'all's time today.
Thanks very much, Greg. I really appreciate your overview of what you guys have learned and done. And other than gloating about the weather, you did a really great job. So to everybody online, thanks for hanging on for the extra 10 minutes. You get 10 minutes bonus education. As I said, we will be circulating answers to the questions. Feel free to keep popping a few questions into the question box for the next few minutes. Next week, we will be discussing design, noon on Tuesday, Central Time. Look forward to having you all back online then, and thank you.